This will be a short lesson on compound interest. You can see that compound interest is very closely related to the regular exponential growth formula because compound interest is exponential growth. This formula is on your formula sheet, and you just need to make sure that you remember what each piece of the formula represents. So A is our final amount. It's the amount that you end up with, including interest. P is our principal. That's our initial value. And I know you are used to seeing that as an A, but this capital P is what we use to represent the principal amount, which is the same thing as the initial value. Now you can see that instead of just 1 plus R, and just a t in the exponent, we have some other letters here. N is the number of times of year the interest is compounded. So R is still your rate as a decimal, but it's important that you put N in the denominator under the R and also multiplied to t in the exponent. So the N goes in 2 places. T is still the time. This time it's going to be in years. Let's practice using this formula. So Brenda invests $4,848 in a savings account. As you read this, I hope that you notice that this is our initial value, right? What she started with. And so in this case, that's our P. And if we label as we go, we'll have less to think about once we plug everything in to set it up. There is a fixed annual interest rate of 5%. That's important to you for the rate. I know that I'm going to need to turn it to a decimal. Remember, you divide by 100, so that is 5 over 100, or move the decimal 2 places to the left, 0.05. Okay, now this is a big difference from the formulas that we've done so far. Compounded 2 times per year. So there's different words that you'll be introduced to for the number of times a year something is compounded. But this specifically says 2 times per year. And N is the number of times per year. So this is our N. Now it's asking us about the balance after 6 years. Let's write the equation first, and then we'll go ahead and replace the number of years, T, with the 6. All right, we don't know the final amount. That's what we're interested in. P is 4,848. 1 plus our rate as a decimal is 0.05 over N, number of times a year, that's 2. Now again, in our exponent, we have N times T, so that is 2 times T. Now you can put this in Desmos. You're concentrating on the right side, and you can replace T with 6 because we know it. So you may be asked to write the formula given the scenario, or you may be asked to find the balance after 6 years. Pause the video and put the right side of the equation in, but instead of T, in parentheses, you should put a 6. Okay, if you put this in Desmos and you do it very carefully, make sure everything that belongs in the exponent is in the exponent. Make sure only the value for N, in this case 2, is what is in the denominator of the fraction, and that you right arrow out of the fraction to close those parentheses. Make sure it all looks right before you trust your answer. I have this long decimal, but we're talking dollars and cents. So the correct answer would be $6,520.02. That is the amount they would have in the account after 6 years at 5% interest, compounded twice a year. I wanted to show you what that looks like on a graph. So I added down here the equation, but instead of putting the 6 in for the number of years, I used X, because we'll say we don't know the number of years, and Y for the answer, because you know Desmos pretty much likes working with X and Y. And then I asked for a table. So it graphed it. I had to zoom way in to see this. Keep that in mind. If you don't see a graph, it might be because the numbers you need aren't showing on your window. So I zoomed way out, actually. And then on the table, I can see for all the different values of X, what my Y would be. So at 0 years, 48, 48. That makes sense because that's what I started with, right? The negatives don't make sense in the context of this problem, but notice Desmos doesn't know that. Desmos shows you the negative side of the graph. Desmos gives you negative values of X on the table. Desmos is smart, but you have to be smarter and use some common sense and think about the context of the problem. So after 1 year, this is the amount in the account. 2 years, that is the amount in the account. And I can enter and add and go to whatever number I want. And if I want to know if I invested this money for 25 years, I can type in a 25 and it shows me that I have over $16,663. All right, so now you know how to write the equation and how to evaluate that equation for a certain number of years. Let's do another one. And this time, we'll try it, you'll try it on your own. Pause the video and try it now. All right, what you may not have realized is what the words compounded quarterly means. Quarterly, a quarter of a year. That means 4 times per year. And so if you don't know that term, now you do. 4 times a year, that means N is 4. And you write your equation, put your R carefully, remember, take 1.01 and divide by 100, or move that decimal 2 places to the left, filling in the gaps with zeros. Also, I made a table in Desmos. I typed this in, made a table, and simply made X values of 10 and 25 to get my answers. Once I wrote my equation and typed it carefully into Desmos, I didn't have to do any math. Let me show you what I mean. So here's my equation. I typed very carefully using X and Y. And then I asked for a table by clicking on the gear and clicking the table icon. And I just added, or even you could replace one of the X values you don't need with a 10 for 10 years and a 25 for 25 years. And it just spits the answers out for you. You'll get more practice with IXL and in class.